Alright, sorry the last video cut off a little bit. So now for the second half of this, we're going to talk about how you actually open a file, how you interact with a file, and how you close a file. It actually turns out that if you've been using printf and scanf, using files is trivial. But there's just you have to have the correct picture in your mind of what the operating system is doing in order to understand what's happening. And once you do, you're good to go, and you can just do whatever you need to do. Okay, so we're just going to go over those functions really quick. Alrighty. Alright, so first thing we're going to do is opening a file. So if you want to open a file, the line is going to look something like this. It's going to be F-I-L-E, all capitals, star, F-P equals F open, and then there's going to be a string that represents the path. So I'm going to use etc/tmp/myfile.txt. Okay, so the first parameter of fopen is the file path. This is the same thing that you'll have used if you've used the My Computer and you've ever looked at like the full file path of things that are in there. Same basic deal. You know, so if this were Windows, then this would be C:/, it would be C:/ and then the path of the file. I'm kind of doing this in like a Linux style where everything starts with a /. But whatever the file path is to your file, that's what you're going to put as your first parameter here in fopen. The second parameter is basically to tell the operating system what is it that you are trying to do with this file. Are you trying to, and the three main things you can do is you can read, you can write, or you can append. Okay, they have really easy to remember things. It's just going to be a string again to tell the operating system what you want to do. And you can either send an R, or you can send a W, or you can send an A. R stands for read, obviously. And what this means is you just want to read the file. If you open a file with R as your mode, is what it's called, then that pointer, that file position pointer that we were talking about, is going to start at the beginning of the file. All right, and we're going to see what that means here in a second. If you use W, then you are opening the file for writing. Okay, and that basically is to say that, you know, it's like I'm trying to write to this file. And again, when you call with W as your mode, it's going to start with the file pointer at the beginning of the file. Okay, that position is going to be right at the beginning. And if it's a new file and there's nothing in it, then it doesn't matter. That's the beginning. It's at the beginning, the end, and everywhere in between because there's nothing there yet. And the last one is A, and that one's called append. And what this is, append is exactly the same as write. The only difference is that that file pointer, that positional cursor in that file, is going to be at the end of the file instead of the beginning. Okay. So if the file already exists and you open it with a mode of A, then everything that you write is just going to go right on the end of the file. Okay. If you use W when you open the file to write, it's going to be at the beginning of the file and it's going to overwrite things that are in the file. Okay? So if we're trying to read a file, we're going to send in this R. If you're trying to write a file, send in W. If you're trying to append to the end of it, send in A. The question comes up, can you read and write to and from a file? And the answer is yes. There are other modes like R+, W+, A+, and you can Google it. There's 1,000 websites out there that all tell you the exact same thing of what all the different modes are that you can open files in. But for now, we're just going to focus on R, W, and A because, frankly, it's actually not all that often that you need to both read and write from a file. Normally what you will do is you will, at the beginning of a program, you will read everything into a file, off of disk into RAM, and then when you're done with it, you'll write everything back and you use just a different file pointer. So it's actually not that common that you want to be able to read and write to a file. All right. So we talked about fopen and we talked about the mode, we talked about the file. What we didn't talk about was this part right here. Okay, this file star right here. So file, all capitals, F-I-L-E. What that is that is a structure. Okay, you've already covered structures, you know what they are. All that is just a predefined structure that's thrown in a header file that's included in all C standard libraries. Okay. When I was saying that you're going to get a handle back that helps you know how to communicate with a file, what I was talking about is this file structure. All right. And if you actually open it and you look and see what's in there, you'll see that there's maybe about a dozen fields. There's absolutely no reason whatsoever that you would have to individually modify the things that are in a file structure. You just don't need to do it. Okay. All you need to do is you need to store it. So whatever fopen gives you, you need to store it in a variable and just use it. And when you're done with it, send it to the close operation to close the file. Okay, so all I'm doing here, this file is a structure. This star means that it's a pointer. We've already used pointers. We're already familiar with those. And then FP is just the name of my pointer variable. Okay, so all I'm doing here is I'm calling this fopen. Let's highlight. I'm calling this fopen function, and it is returning to me a pointer to a file structure, and I'm naming it FP. And the fact that it's a structure is really of no consequence because it just doesn't matter what's inside of it. All we need to do is just store it so we can use it. Alright, so that's how we open a file, and we can open as many files as we want. Careful though, don't open the same file twice. In a program, you can get some strange behavior if you do that. Okay, so once you open a file, just reuse the file pointer. Alright, the next thing is how to read and write to a file. So let's start with reading to a file, or reading from a file, sorry. Actually, I take that back. Let's start with writing to a file, because writing is a tiny bit easier to understand. Okay, so let's say that I have file star fp equals fopen /var /file.txt. And I am opening this for writing. Now, let's say that I want to write some data. Let's say that I want to say, let's say that I desperately wanted to put a file on disk that says what my age is. Okay, so I say int my age equals 10. I wish, not really. Okay, so if I want to put this into a file, all I'm going to do is I'm going to use, if I want to print something in the console, I use printf. That's a pretty standard function. If I want to put it in a file, all I'm going to use is a function called printf. The exact same function, just with this little f in front of it. That f obviously stands for file. It takes almost the exact same parameters as printf. The only difference is that the first parameter is going to be my file pointer. So I'm going to say fprintf, and then as the first parameter, fp. Send that in. This tells the operating system what file are you trying to write to. And I say, well, I open this file up here, and so that's the file I'm going to send. Please write to this file. After that, it's exactly the same as a printf function. Next thing is what I actually want to do. I say my age is, and I can use the little %d that is standard in printf statements, and then I can say my age. And boom, that's it. Okay, so now if I were to look at that file, if I were to open it up, so I'm over here on disk. After this line runs, this line tells the operating system says, hey, over here in this file, that's in /var/ file.txt, put my age is 10. Boom. And the disk is going to say, good to go. The operating system is going to return back and say, done. And that's all it takes. Okay? So, after this line, this file is going to have my age is 10. So, now let's talk about the file pointer here. Okay? So, let's walk through this line by line. Okay, before I wrote anything to this file. So, when I was right here, after I opened the file, this is what the picture on disk looked like. There was a file called /var/file.txt. It was empty because I said open this for writing. It didn't exist before. And so now there's a little pointer that points to the beginning of this empty file. Immediately after, or I should say when I start writing, the operating system starts writing at that file pointer. Okay? So when I said fprintf my age is mod d, and then put in 10, what it put in is it said my age is 10, and then it moved, oops, erased too much, and then it moved that file pointer to the end. It said, you've written stuff. File pointer is now right there. So now if I put in a second line, and I say fprintf dot dot dot, that's cool. And again, this is just like printf. I don't have to have parameters. I don't have to have parameters after that string. I can do it exactly the same way. So if I just say that's cool, then the operating system says, okay, after this, I'm going to put dot dot dot. That's cool. It's going to start at where that file pointer is. Still got too much. It's going to write and update the file pointer to point to the end right there. Okay. Every time I call fprintf, it's going to keep on moving that file pointer, and it's going to keep on moving it to the end of what it wrote. And in this way, when I write multiple times, it just keeps on adding to the file. It's not going to overwrite anything unless I move that file pointer, which you can do, but there's no reason for you to do it in normal circumstances, especially not at this point. All right. So that's how we write to a file. Super, super simple. All right, now let's talk about reading from a file. So I'm going to say file star fp equals fopen /var/ file.txt r. So I passed in a mode of R because I actually want to read from this file. So now over here on disk, there needs to already be a file called var file.txt. And inside this file, there already needs to be something. Okay. So what I am going to do is I am going to say let's just say there's a whole bunch of numbers. Let's just say that there's the Fibonacci sequence for whatever reason. So 1, 1, 2, 3, 5, and there are spaces in between these. 1, 1, 2, 3, 5, 8, 13. Da, 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 da. Okay, that's my file, and I want to read it in for whatever reason. So when I open this for reading, I get a pointer to this file. The operating system gives it to me. And as part of my file pointer, or as far part of my file structure, there's a pointer. And for reading, it starts at the beginning of the file. Okay. If I want to read from this file, I'm going to do it if you're familiar with the function scanf that you can use to request input from the users. Again, there's the exact same thing, just with a file. Okay, so I can say fscanf. Scanf doesn't immediately has a string as its first parameter. Fscanf, the first parameter, is the file you want to read from. So fp. And now I'm just going to say mod d. Mod d. Why not? Let's do 2. And I'm going to define up here int first num and int second num. Okay. And now in the same way that for scanf, if I want it to actually put the values, into these variables, I need to send the address of the variable. And the way that we do that is by just doing ampersand first num, ampersand second num. By doing that, what I'm basically doing is I'm giving this function fscanf, I'm giving them permission to change these variables. And that's exactly what I want. What I want is by the end of this line, I want first num to have a number in it, I want second num to have a number in it. If I didn't use those ampersands, nothing would change. And that would not be good. Okay, so if I look at this, after this line runs, what it's going to do is it's going to scan through the file, and it's going to be looking for numbers, because that's what that %d means. And after this, first num will be equal to 1, and second num will also be equal to 1. Okay? And the most important change, I'm going to try to do this even though it hasn't worked thus far. Holy cow, it worked. The biggest change that's going to happen is not only did I read these first 2 numbers out of the file, but my file pointer moved. It moved to between the 2 1s and that 2. Okay? And what that means is that if I make a second call, so if I say int third num, and I say fscanf, I send in the file I want to read from, I say %d, and then I say ampersand third num. It's going to start reading at that file pointer, which right here is right before the 2. And therefore, after this, third num is going to be equal to 2. Okay? This should look really similar to how you accept input from a user on the console, and that is not an accident. If anything, it is very intentional that we make it so that reading and writing to and from the console is almost exactly the same as reading and writing to and from a file. Okay? And if you actually dive under the covers, you'll actually find that reading and writing to the console, the operating system treats it exactly the same as reading and writing to a file. The console is just a special file that it's displaying to the user right away. Okay, so in general, reading and writing to a file, all it is going to be is it's just going to be the exact same way that you were doing everything in the console before, but now instead of showing that to the user, we're just putting it on disk. And you just have to understand that the idea is that there's this cursor here that keeps on moving. Every time we read or write, it's pushing that cursor along. All right, so that when we keep on calling it, we keep on getting a different answer. All right, so that's reading and writing to a file. The last thing you need to do that is super simple is closing a file. Always remember to close files, because like I said, the operating system may lie to you. It may not actually read and write. Well, it would always read from a file because it has to give you the input. But it may not actually write to a file because it may just be holding on to that and saying, I'll get to it eventually. This is very taxing stuff. So in order to close a file and in order to force the operating system to actually get around to doing stuff, all you do is you just call fclose, and then you send in the file pointer. And you're done. And that's how you close a file. Couldn't be simpler. All right. One more thing that I want to go over. I've kind of, for some reason, this was difficult for me when I first started programming. It seems super obvious now, but operating systems have done such a good job of pulling the wool over your eyes that this is actually a surprise for people. We're going to talk about this file path. Most especially, we're going to talk about that file extension. Okay. So if I say file, you get a new copy here, file star fp equals fopen, and then I have var myfile.txt, and I'm going to read it. Okay. If I do this, you'll notice here that I have this file extension. And people are super used to the idea that a file extension tells the operating system how to treat a file. Okay, so a .txt file is going to open in Notepad, and a .ppt is going to open in PowerPoint, and a .exe is an executable that's going to run. Okay, and so you may be wondering, okay, well, how do I use these file extensions? How do I tell the I'm writing a program myself now. I'm actually manually writing these files. How do I tell the operating system what file extension I'm using, what's supposed to be happening here? And the truth is that it's all a sham. Every single bit of it. All right? That .txt is actually part of the file name. The only thing that's special about it is that there's a dot and then a txt on the end. You don't need it. You could omit it. You could change it. You can choose whatever you want. The operating system, when you go into My Computer, may treat that file differently when you double-click on it. But as far as once you're in the computer program and you're actually reading like this, it's either a text file or it's a binary file, and you can do anything you want with it. Okay? If you wanted to, you can open a .exe and just start reading stuff out. It's mostly going to be garbage because you're not reading it correctly, probably. But you can just do it. So I can just say fopen /var/myfile. Boom. And I'm just going to be, let's actually make it for writing just for demonstration. Okay. Boom. That will work perfectly fine. And then the file that you're going to end up with is just going to be a file called myfile with no file extension. And when you open it up in My Computer, it's going to have this blank little icon. And if you double click on it, the computer's going to be like, I don't know what you want me to do with this because I don't know what the file extension is. Okay? But there's nothing special about the file extension. The file extension is just a hint to the operating system of here's how you probably should treat this file. Okay? So if you want to, if you're trying to use a file extension, if you're trying to save files using that, all you do is just include it in the file name. If you want it to be a txt file, use .txt. If you want to make a special file extension that only your program can open and close, just pick one. Just, .abc. Why not? That's your file extension now, and you know how to read and write it. Okay? The file extension is just a part of the file name. It is just a hint to the operating system of here's how you might be able to use this. But that's all it is. Okay? So you don't need to do anything special for file extensions. You just need to make sure you include it in that string if you want it. Anytime that I'm writing a text file, I will always include .txt on the end because the operating system always knows how to handle that. It always just opens it as a text file in some text editor. File extensions you've been dealing with are .cpp and .h. Those are things that just tell the operating system, hey, this is a text file, but you should probably open it in Visual Studio. These are all just hints, but you can use whatever you want. It's just a part of the file name. Okay. For some reason, when I started programming, that was a mystery to me. I thought that I had to I thought the file extension was going to have to be like a different parameter. I thought that you were going to have to tell the operating system how to do this, that, or the other thing. No, it's just part of the file name. Alrighty, I think that's pretty much it for files. You can do more advanced things. There are other functions that are out there, like reading and writing binary files is a thing. But for the most part, everything that works for reading and writing to and from the console, whether you're requesting user input or you're writing out to the console, everything that works for that works for files as well. You just have to have this picture in your mind correctly of realizing that there are two regions of memory, one RAM, one in disk, and that you have this file pointer that's just pointing to somewhere in the file that says I'm going to either start writing from here or I'm going to start reading from here. And every time you read and write, that gets pushed along. And I think that's all I can describe for now. If you have questions, we can go over them, but that's it for now.